Okay, so here we go with 5.6 part 1, which is transforming just sine and cosine functions. So again, you are not going to be responsible for transforming any of the tan, cotan, or reciprocal trig functions. So when we're looking at this, we are looking at transformations on sine and cosine, which are going to look very similar to each other. And what I want you to notice is that they have the A, they have the B, the C, and the D, and they don't change what they mean. So if you look here, you've got the A in front of the sine function, and you've got the D on the end. These are both transformations on Y. So A is going to be your vertical stretch or compression. The other thing that A can do is that it can reflect your Y values, because it's affecting Y, over the X axis. Moving on to B, B is in the bracket with the X, so B is a transformation on X, which means it's your horizontal stretch and compression. It can also reflect your X values over your Y axis. Now we move on to C. C is your moving left and you're moving right, so your phase shifts. And D is your transformations up or down. And again, it's not any different than what we've been doing. The biggest difference is that how it's going to affect these specific graphs. So if we look at a specific graph, so for example, we look at a cos x graph, we've got our gray graph here being our regular cos x graph. So remember your unit circle, cos is following x, so it goes 1, 0, -1, 0, 1. And if we look at the features of your cos x graph, it has a period of 2 pi, it has an amplitude of 1, it has a domain of xer, and it has a range of -1 to 1. If we look at the graph of y equals 1.5 cos x, so this is your blue graph here, instead of starting at 1, it's starting at 1.5 because it's been stretched vertically by a factor of 1.5. So it goes up to 1.5, down to 0, down to -1.5, up to 0, up to 1.5. So what's that going to affect? It does not affect your period, but it does affect your amplitude. Your amplitude, so I didn't need to write that, is 1.5. Your domain is xer, and your range would be -1.5 up to 1.5. If we look at the next transformation, which is y equals -2 cos x, this is our purple graph. So there's two things that have happened. One, our amplitude has changed. So you've been vertically stretched by a factor of 2. So instead of going up to 1, you'd go up to 2. But it's also been reflected in the y values over the x-axis. So you're getting this point here where you're starting at -2, then you go up to 0, up to +2, and so on. So your period is still 2 pi. Your amplitude is 2. It doesn't matter that it started down at -2. What matters is that it is has 2 units from your center line. Your domain is still xer, and your range is going to go from -2 to 2. So what does A affect? Well, A affects the amplitude. The amplitude is the absolute value of A. When A was greater than 1, you got a vertical stretch. Vertical stretch. When A is greater than 0 but less than 1, you get a vertical compression. And when A is less than 0, you get a reflection in the y values over the x-axis. So what if this was a sine graph versus a cosine graph? Well, we've already decided that amplitude is the absolute value of A. So if you have a 3 cos x graph, your amplitude's 3. Well, if it's a -5 sine x graph, your amplitude is 5. It doesn't matter whether you're sine or whether you're cosine. The absolute value of A is how high or how low you go from the center line. So if your A value is 1/2, then your amplitude is 1/2. So looking at what a value of A can affect, it can affect your amplitude. It does not affect your period. It does not affect your domain. It affects your range. It does not affect your x-intercepts, and it does not affect your center line. Your center line is y equals 0. So if you stretch that by a factor of 3, it's still 0. Moving on. If we wanted to graph some of these, we're going to graph y equals -3 sine x. Now, I'm going to teach you actually 2 ways of how to do this, and then you can kind of look to see what makes the most sense out of you. So what I'm going to start with first is how we would have done it potentially in chapter 1. So we're graphing y equals -3 sine x. So the first thing I'm going to do is I'm going to graph y equals sine x. So I'm going to start with a gray marker just because this is not going to be my final graph. So I'm going to start with gray and I'm going to graph a sine graph. Sine graph starts at 0. At pi by 2, it goes up to 1, and I find pi by 2 because it's halfway to pi. Then at pi, it goes down to 0, and then at 3 pi by 2, it goes to -1, and then back up to 0. This is my normal sine curve. And if I wanted to stretch it going the other way, or extend it, I should say, then I could just put those dots, and I could make it go the other way. So this is telling me that I am going to vertically stretch. So if you look at the equation, this tells you that you are going to vertically stretch by 3, and you're going to reflect in the x-axis. So if I switch my pen color to something like red or purple, whatever I see, so we're going to graph this transformation. So I'm going to stretch my y values by 3. So 0, 0 is going to stay 0, 0. This value 1 is going to get stretched by 3 and reflected over the x-axis. So it's going to go down here. My 0, 0 is going to stay the same, or my y value is 0. This one's going to go up to 3. And then I'm going to go, oops, sorry, not there. Get my little eraser. Okay, then make sure that you go over here and I go up to 3. And then I go back to 0. And again, I can copy this on the other side. And this is my final graph. And this is a great way of doing it. So the only reason I'm going to teach you any way different to graph this is because we are going to be doing more than just this transformation. If this was the only transformation I was doing, this is how I would graph it. But because we're going to have to do some things that are more complicated, I'm going to guide you through just a bit of a different way to come up with that same graph in the end. And so what that's going to involve is some of the stuff that I've got written over here on the side. So this says, first off, is that you want to figure out what your scale of your graph is. And the reason you want to do that is you want to figure out, where is pi by 2? Or what is a period of 2 pi? Or kind of what is every grid line worth? So to figure out your scale, what you do is you come to your axis and you say there's 1, 2, 3, 4 grid lines until I get to pi. So my scale is pi by 4. Then I look at, what do I want the amplitude of this graph to be? Well, it's going to be 3. What's the period? Well, nothing's happened, so it's going to be 2 pi. Then we talk about this key point idea. And the key point is that if you look in your coordinate plane, right, in your unit circle, you've got one key point when you've got x is 1 and y is 0. You've got another key point at 0, 1. You've got another key point at -1, 0. And then you've got a last key point at 0, -1. And then this one repeats again. So there's 1, 2, 3, 4 key points and then a repeat. So in 2 pi, you're going to have 4 key points, which means that your key points are going to happen every pi by 2, which we already knew, but we only know because we have a period of 2 pi, and we're going to be transitioning to not having a period of 2 pi pretty soon. So what we want to look at is how often are our key points going to happen? Well, if our grid lines are each worth a pi by 4, then every 2 grid lines, you are going to have a key point. Grid lines. So what does that mean? Well, when I graph, I'm going to look back at the fact that this is a sine graph, and I'm going to start at 0, 0. Then I'm going to know that every 2 grid lines, I'm going to have a key point. And what is that key point? Well, from 0, 0, I'm going to go down to -3 in 2 grid lines. And then in another 2 grid lines, I'm going to come up to 0. And then in another 2 grid lines, I'm going to go up to 3. And then in 2 grid lines, I'm going to come down to 0. And that gives me this nice graph of y equals -3 sine x. And then to the left, 2 grid lines up to 3, 2 grid lines down to 0, 2 grid lines down to 3, and 2 grid lines back to 0. And I get this beautiful graph that again has been stretched by 3 and reflected over the x-axis. And the domain of this graph is XER, and the range is from -3 to 3. All right. Again, this would be the point in the video where you should pause and you should attempt to do this one by yourself, and then come back and you can hear me talk it through if you need me to. So this is y equals 1/2 cos x. So if I'm looking at this one, this is going to be a vertical compression by 1/2, which means that the amplitude is going to be 1/2. The period is still going to be 2 pi because we haven't affected that yet. My key points are going to happen every pi by 2, which looking at my scale is still 1, 2, 3, 4 grid lines to get to pi, so it's still pi by 4. So it's going to be 2 grid lines I'm going to have my key points. And so for a cosine graph, instead of starting at 0 like sine, it starts at 1. But I'm going to compress that vertically by 1/2, so I'm going to start at 1/2. And then every 2 grid lines, I'm going to go down to 0. 2 grid lines, I'm going to go down to 1/2. 2 grid lines back up to 0. 2 grid lines up to 1/2. And again, you do not have to do it like this. You can draw your base graph and transform it. So 2 grid lines down to 1/2, or 0. 2 grid lines down to 1/2. 0 and 1/2. You have to fill your grids, no choice. You can't just draw one cycle. And there you go. There's y equals 1/2 cos x. And the domain of this graph is XER, and the range is -1/2 to 1/2. All right, moving on to the next transformation, which is B. So you always do your transformations in order from left to right. And so transformation B is your horizontal stretches and compressions. So what I want you to look at is all the different graphs. So first off, we've got 4 different graphs. We've got the first one being y equals sine 4x. The second one being y equals sine of -1/2 x. Then we've got cos of 1/2 x, and we've got negative cos of -2x. And what they've done is compared this to all your base graphs for you. So if you look at the first one, this one sine equals 4x graph, you'll notice that the gray graph in the background is your y equals sine x graph, and it's been compressed horizontally by 1/4. So what does that mean? Well, if we look at the y equals sine 4x graph, the period has changed. The period is no longer happening over that stretch of 2 pi. Well, how would the period change? Well, if the period is 2 pi, it's been compressed by a factor of 1/4. My new period is pi by 2. And if you look up at this graph, you've got this point 0 where it goes up, and then you've got a point here where it goes up again. Not too sure if you can see the purple marker that I'm using on a purple graph, but there's a point here and there's a point here. And this is halfway to pi. So one cycle is happening in pi by 2. Going along the theme of this y equals sine 4x graph, let's talk about key points. So our key points in 2 pi happened every pi by 2. If my scale, or if my period is now pi by 2, and I have to fit 4 key points in that pi by 2 graph, it means that my key points are going to happen every pi by 8. So I'm getting 4 key points between 0 and pi by 2. So they're going to happen every pi by 8. How many cycles do you get? Well, normally between 0 and 2 pi, you only get 1 cycle. With this one, you're actually going to get 4 cycles because you've compressed it by 4. What's the amplitude? Well, it's 1. The domain is still x is all real numbers, even though it's been compressed. And my range is still -1 to 1. So when we look at the next graph, y equals sine of -1/2 x, when we look at that as a transformation, x is opposite as it appears. So I would guess that this would be a stretch by a factor of 2. And if you look up here at the second graph, you'll notice the gray graph is your normal graph and the blue graph is your transform function. And you're only getting half of your graph between 0 and 2 pi. You're just getting the downward part. And so what that means is that it's not happening as often. So if you look at it from a period point of view, your period is 2 pi, and it's being, so some people say that you can divide by that b value. So it's being divided by 1/2, which is actually timesing by 4. So your period is 4 pi. That means that your key points, there's going to be 4 of them in that period, are going to happen every pi. So if you look up here at the blue graph, okay, you've got 0 and then you go down to -1 at pi. That's your next key point. And then you go back up to 0 at 2 pi. If we keep going with this y equals sine of -1/2x graph, the number of cycles you get from 0 to 2 pi is you only got half the cycle, but the amplitude was still 1. The domain is still XER, and the range is still -1 to 1. If we go to the next graph, which is y equals cos of 1/2 x, it's going to be very similar to the one we just did. So it's going to have a period of 2 pi divided by 1/2, or 4 pi. It's going to have key points every pi, because you're going to take that period and you're going to divide it by 4. It's going to have half a cycle. It's going to have an amplitude of 1. It's going to have a domain of XER, and it's going to have a range of -1 to 1. The last graph we're going to look at is y equals cos -2x. So looking at these transformations, this is going to give you a reflection in the y values over the x-axis. This is going to give you a reflection in the x values over the y-axis. And this is going to be a horizontal compression by 1/2. In other words, my period was 2 pi, but now it's going to be 2 pi by 2. So my period is going to be in pi. So if you look up at this graph, so there's a couple things happening. Number one is that your graph is starting at -1 instead of starting at 1, and that's because it's been reflected in the y values. And it's been compressed by 1/2. So if you look at this bottom point, you get another bottom point here at pi. And then it's also been reflected in the x values over the y-axis. So that doesn't really kind of affect too much because of the cosine graph. It is already kind of symmetrical about the y-axis. So your key points were supposed to be there's 4 of them within that period of 5, or period of pi. So you're going to have key points at every pi by 4. So your cycles that are going to happen is that you did have 1 cycle between 0 and 2 pi, but now you've been compressed by 1/2, so all of a sudden you're going to get 2 cycles between 0 and 2 pi. Your amplitude is still 1, your domain is still XER, and your range is going to be -1 to 1. So what did the value of B affect? It did not affect your amplitude. It did affect your period. It did not affect your domain. It did not affect your range. It will affect your x-intercepts, which we'll talk about in a bit, and it did not affect your center line. Therefore, the period is always 2 pi divided by the absolute value of B. When B is greater than 1, you get a horizontal compression, opposite as you would think, because if you divide by 2, it compresses. And when B is between 0 and 1, you get a horizontal stretch. And when B is less than 1, you get a reflection in the x values over the y-axis. Okay, so let's try some. So if I was going to graph y equals 2x, again, you could start with your y equals x cos x graph, and then you could compress it by 2, but I find it harder. So what I'm going to do is kind of go the way that I was talking you through it before. So we're expecting in this one, we're expecting a horizontal compression by 1/2. Our scale is still pi by 4. I'm using the same grid for you. Okay, our amplitude is going to be 1 because there's no a value. My period is normally 2 pi, but it's going to be 2 pi divided by the absolute value of B. So my period is going to be every pi. So I'm going to get 1 complete cycle between 0 and pi. My key points are going to happen every pi by 4 because there's 4 key points in every period. And so it's going to be every grid line I'm going to have a key point. I could fill out the bottom part now as well. My domain is going to be XER. My range is going to go from -1 to 1. Okay, but let's figure out how to graph this. So this is a cos x graph. So a cos x graph normally starts up here at 1, okay? And there's been nothing to change that. There's been no a value, and then we haven't talked about anything else. So we're going to start here at 1, and then every grid line, I'm going to do a key point. So I'd go down to 0. I'd go down to -1, I'd go back up to 0 and back up to 1. And that's 1 complete cycle between 0 and pi. And then I can just keep this going. So every grid line, I'm going to draw a point. And again, you can do this as a transformation, but the problem is that you're going to bring in more points than your original graph had, which makes it kind of tricky because you just have to extend the pattern anyway. So you end up having to be able to do this part anyway. So why not do it from the beginning? So there's in the other direction. And back up to 1. And then we just trace over. There we go. And again, this would be the part in the video that would be a really good idea to try one, but I will talk this through as well when you're ready for it. So with this one, I'm looking at it being a horizontal stretch by 3. My scale is different in this graph. So there are 2 grid lines between 0 and pi, so my scale is pi by 2. My amplitude of this graph, there is no a value, so it's going to be 1. My period is normally 2 pi, but you're going to divide that by the b value. So all of a sudden my period is going to be 6 pi, which means my key points, there's going to be 4 key points in that period of 6 pi. So my key points are going to happen every 3 pi by 2. How many grid lines is that? Well, if every grid line is worth pi by 2, and I want to go 3 pi by 2s, it's going to be 3 grid lines for a key point. So if I was to graph this, it's a sine graph. It normally starts at 0, 0, and there's nothing to change that. So it's going to be horizontally stretched by 3. So every 3 grid lines, I'm going to go up to 1. So 1, 2, 3, I go up to 1. 1, 2, 3, back down to 0. 1, 2, 3, down to -1. 1, 2, 3, I go back up to 0. And so I'm getting one complete cycle between 0 and 6 pi. And then we go in the other direction, 1, 2, 3 grid lines down to -1, 1, 2, 3 grid lines back up to -3 pi, or 0, sorry. 1, 2, 3 grid lines up to 1, and 3 grid lines back down to 0. And then there's 2 cycles of this sine graph. The domain of this graph is XER, and the range is -1 to 1. Oops. All right, moving on, tying these two things together. So if we just look at these graphs, I want to make sure that you can find amplitude and period from an equation, because that could be a good multiple choice question. So for this one, it's the absolute value of A, so the amplitude is 3. The period is 2 pi divided by your B value, so your period is pi by 2. And just to practice that, the key points idea is that your pi by 2 is going to split up into 4 key points, and so they're going to happen every pi by 8. I would pause the video, try the next 3, come back and check your answers. So this one has an amplitude of 1/2. The period is going to be 2 pi by 1/4, so that's going to be 8 pi. And then your key points, you're going to split that 8 pi up into 4 key points, and they're going to happen every 2 pi. The amplitude of this one's going to be 5. Your period is going to be 2 pi divided by b, which is just pi, and your key points are going to happen every pi by 4. The last one, my amplitude is 2. My period is 2 pi divided by 1/2, which is 4 pi. And then they're going to happen every period. You're going to have 4 key points. So they're going to happen every pi. So practicing graphing a couple. We've got this one, y equals 2 sine 1/2 x. Looking at this graph, we've gone back to my scale of pi by 4. The nice thing is in your homework package, I've given you all the grids for graphing, so you don't have to come up with these scales, which will hopefully make your life a little bit easier. You'll just have to figure out what the scale I used is. The amplitude is the absolute value of A, so it's 2. The period is 2 pi by B, or 4 pi. Your key points is going to be 4 of them in that 4 pi cycle, so they're going to happen every pi. Then we're trying to figure out how many grid lines is pi. Well, if it's a scale of pi by 4, then you're going to have 4 grid lines to get every key point. And your domain is going to be XER, and your range is going to go from -2 to 2. So it's a sine graph. Sine graphs start at 0, 0. This one's going to start at 0, 0. It's going to have an amplitude of 2, so I'm going to go up to 2, but it's going to take me 4 grid lines to do that. So 1, 2, 3, 4 grid lines. So at pi, I'm going to go up to 2. 1, 2, 3, 4 grid lines. So at 2 pi, I'm going to go down to 0. Then I'm going to go the other way. 1, 2, 3, 4 grid lines. So every pi, I'm going to go down to -2. And then in 4 grid lines, 1, 2, 3, 4. I'm going to go back up to 0. And so here is my final graph. Ooh, not bad this time. This is my final transformed graph that has an amplitude of 2, a period of 4 pi. So it took 4 full pi's for this whole thing to happen. And there you go. Moving on. Sorry, I've been talking all day. The next thing we're going to look at is a phase shift. So we're going to be looking at moving our graphs right and left. So remember, the graph will move the opposite way the sign looks like it's going to move. So if it's going to be an x plus c in the bracket, that's actually going to move it to the left. And if it's an x minus c in the bracket, it's actually going to be moved to the right. All right. Oh, there's a little point here that says the C value will affect the scale you use. I used to make students come up with the scale, but then I decided that's just too hard for now. So you had to have a common denominator between your B value and your C value, and I just scrapped it and I give you a scale. Okay, so here's an example of our phase shift. So this is going to be a phase shift left because it's a plus, so we're going to go left. Sorry, I'm in an eraser tool. We are going to go left pi by 3. And what we want to look at is how that's going to affect our graph. Well, our scale of this graph, there's 1, 2, 3, 4, 5, 6 grid lines to get to pi. So our scale is pi by 6. The amplitude, because there is no a value, there's a 1 here, so the amplitude is 1. The period is going to be 2 pi. There's no b value to change that. So my key points are going to happen every 2 pi by 4 or every pi by 2. Now I want to look at how many grid lines that is. Well, pi by 2 with a scale of 6 is 3 pi by 6. So it's 3 grid lines. Then we want to look at our phase shift. Our phase shift is going to be pi by 3. And so if we look at that from a grid lines point of view, pi by 3 is going to be 2 pi by 6. So one thing you could do, I mean, if it does help you, is you could kind of put in values. Like this would be pi by 6. This would be 2 pi by 6, which maybe you'd want to simplify it as pi by 3. This would be 3 pi by 6, which would be simplified to pi by 2. And then you can kind of see where things are going to go to help you out. So what we're going to do is look at the fact that this is a cosine graph. A cosine graph follows x, so it starts at 1. But instead of starting at 0, 1, you're going to move this left 2 grid lines to start at negative pi by 3. So this would be negative pi by 3 or negative 2 pi by 6, 0 or 1. And then every 3 grid lines, you're going to have a key point. So 1, 2, 3 grid lines down to 0, 1, 2, 3 grid lines down to negative 1, 1, 2, 3 grid lines back up to 0, 1, 2, 3 grid lines up to 1, 1, 2, 3 grid lines back down to 0, 1, 2, 3 grid lines down to negative 1. And then we can't fit that way. So then we just go like this and we connect the dots. Zoom. And again, this would be one that would be easy enough to again start with your base graph and then transform it just by moving every point left pi by 3, but it's kind of like a conveyor belt where things will just sort of keep coming that weren't shown on the graph and you just have to keep extending it anyway. Okay, looking at the domain and range, the domain is XER and the range is negative 1 to 1. Okay, moving on to this one. So again, this would be a great place for you to take a pause and try this one on your own and then come back and I can do it with you. So looking at this one, there's 1, 2, 3, 4, 5, 6, 7, 8 grid lines to get to pi. So the scale is pi by 8. There is no a value, so your amplitude is 1. There is no b value, so your period is 2 pi. Your key points, there's going to be 4 of them in that period, so they're going to be every pi by 2. Pi by 2, again, you're looking for how many grid lines that will be. Well, pi by 2 is 4 pi by 8, so it's going to be 4 grid lines. So every 4 grid lines, you're going to have a key point. Your phase shift was right. Sorry, I should have put that at the top. Our phase shift is right pi by 4. So our phase shift down here is going to be pi by 4. And again, if we want to know how many grid lines, we have to give it a denominator of 8. And so it's going to be 2 pi by 8. So every it's going to phase shift right 2 grid lines. And then your domain, nothing's going to affect it, so XER and -1 to 1. Okay, so now we're looking at, and you'll notice I haven't even noticed if it's sine or cosine yet because it doesn't matter. They're kind of similar in how you do this, but it's a sine graph. So a sine graph normally starts at 0, 0, but we're going to move it to the right pi by 4. And again, you could label these. You could call this one pi by 8. This is 2 pi by 8 or pi by 4. And if it helps you to have those labeled, it's not a bad idea. So instead of starting at 0, 0, I'm going to start right at pi by 4, 0. And then every 4 grid lines, I'm going to have a key point. So in 1, 2, 3, 4 grid lines, I'm going to go up to 1. In 1, 2, 3, 4 grid lines, I'm going to go back down to 0. In 1, 2, 3, 4 grid lines, I'm going to go down to -1. And in 1, 2, 3, 4 grid lines, I'm going to go back up to 0. And then same thing the other way. 1, 2, 3, 4 grid lines down to -1. 1, 2, 3, 4 grid lines. Back up to 0. And so then we connect our dots with a nice smooth curve, as smooth as you can make it. And there we go. So this is our transformed graph that's gone right pi by 4. So what did the value of C affect? Did it affect our amplitude? No. Did it affect our period? No. Did it affect our domain? No. Range? No. Will it affect our x-intercepts? Yes, we will talk about that in a bit. And it did not affect our center line. All right, the last transformation we're going to talk about is D. D, if it's greater than 0, it moves your graph up. Here's some examples. If you've got plus 0.5, your blue graph is your gray graph moved up 0.5. If it's negative, it's going to move down. And again, this purple graph is your cosec graph moved down 2. And here's an example of it moving sine. If it's plus 3.5, it goes up 3.5. So what we want to look at is what does it affect? Well, does it affect our amplitude? No. It still goes up 1 and down to -1. Period? Nope. Domain? Nope. But when I say it goes up and down 1, it's not to 1. It's an amplitude of 1. So if you look at your range, so for example, this guy, your range is different. Now, I don't like that they use the 3.5. I'm going to use this guy. So we've got the y equals sine x minus 4. So the whole thing's been moved down 4. But your amplitude is still 1. So your D value, you go up however much your amplitude is and down however much your amplitude is. So this would be adding A and this would be subtracting A. So if you went down -4 and I wanted to know how high it would go, I'd add 1, it goes up to -3. And to go how low it would go, I subtract 1, I go down to -5. And that's going to give me my range. So the range of this blue graph is from -5 to -3. So now let's look at this one. If my D value is 3.5, I go up 1 from there to 4.5, and I go down 1 from there to 2.5. So my range of this guy would be 2.5 to 4.5. And so we can find the range simply by knowing the amplitude and the displacement. So most importantly, D is the only transformation that affects, oh sorry, I should finish this off. Did it affect your x-intercepts? Yes, everything affects x-intercepts, but it affects that center line, right? So it affects that place that you oscillate above and below. So it's the only transformation that affected the center line. When you're graphing these, you have to go through all the same steps. So we're expecting this one to be down 4. If we want to figure out the scale, we go 1, 2, 3, 4, 5, 6, 7, 8 grid lines to get to pi. So my scale is pi by 8. The amplitude, there's a 1 here, is going to be 1. My period is going to be 2 pi, which means my key points are going to happen every pi by 2. And again, how many grid lines is that? Well, with a denominator of 8, that's going to be 4 pi by 8. So every 4 grid lines, you're going to have a key point. Phase shift, oh, thank goodness there isn't one. And then the vertical displacement we decided was down 4. So before I even start, could I figure out this part? Well, the domain is still going to be XER. There's nothing that's going to affect your domain. But your range, you've been moved down 4. Your amplitude is 1. So you're going to go up 1 and you're going to go down 1. So you're going to go up to -3 and down, oh, sorry, I don't know why that wrote there. So you're going to go up to -3 here and you're going to go down to -5. So your range is going to be -5 to -3. So how are we going to make this happen? Well, we're going to look at where we start. So again, I haven't even looked if this is sine or cos, but this is a sine graph. Normally my sine graph starts at 0, 0, but I'm going to move it down 1, 2, 3, 4 grid lines. And then from here, every 4 grid lines, because that's where my key points are going to happen, I'm going to go up 1 or down 1. So 1, 2, 3, 4 grid lines, up 1. 1, 2, 3, 4 grid lines back to the midline. 1, 2, 3, 4 grid lines down to -5. 1, 2, 3, 4 grid lines back up to 0 or the center line. And then going the other way. 1, 2, 3, 4 grid lines down to -5. 1, 2, 3, 4 grid lines back up to that center line. And this would be the graph of y equals sine x minus 4. All right. So putting this all together, when you're putting all of these transformations together, we have to look at what each one is going to affect and how we're going to graph it when there's more than one thing to do. So the A value. The A value is a transformation on y. It's a vertical stretch and or compression. So I'm trying to use short forms. If you look at my note keys, I've written these all out really nicely. But for the A value, you get vertical stretch or compression. What does it affect on your graph? Well, it affects the amplitude. In fact, the amplitude is the absolute value of A. It'll also affect your range. Your Y values are going to go down to -A and up to +A. If we look at B, sorry. Oh, and sorry, I didn't put that in there, but you can also have a reflection. It's not in my key, in y values over x-axis. Okay, so the B value can be a horizontal stretch and or compression, and it can reflect the x values over the y-axis. So what does that affect? Well, it definitely affects your period. In fact, your period can be found by going 2 pi divided by the absolute value of B. It can also affect your key points because you're going to take your period. So if this is period equals, you're going to take your period and you're going to divide those by 4. The C value is a horizontal phase shift. So it's going to make you go left or right. And what's that going to affect? Well, it's going to affect where you start. You know, are you starting at 0, 0 or 0, 1, or have you moved left or right? And it's also going to affect your x-intercepts, right? In fact, a lot of these are going to affect x-intercepts. This is going to affect your x-intercepts. This one won't, though, the vertical stretch. Okay, and then plus D is going to be a translation. Translation. You could be specific and call it a vertical translation, up or down. And the main thing that it's going to affect is your center line. I don't know what I'm doing there. Center, I can't spell. Center line, your center line is going to be at y equals D, and then it's going to affect your range. So your graph is going to go from D minus A up to D plus A. All right. So let's look at one that we can transform fully together. So let's start off by seeing what is the scale of this graph. So there's 1, 2, 3, 4 grid lines to get to pi. So your scale is pi by 4. Is my amplitude going to change? Yes, there's a 3, so my amplitude is going to be 3. My period is going to be 2 pi. There is no b value, so it's just going to be 2 pi. My key points, there's going to be 4 of them, and so it's going to be every pi by 2. Since my scale is pi by 4, pi by 2 is 2 pi by 4, so there's going to be every 2 grid lines I'm going to have a key point. Do I have a phase shift? Yes, I do. I am moving right pi by 4. So this is going to affect my starting point. Since my scale is pi by 4, it's going to be 1 grid line that I phase shift. Is there a vertical displacement? There's no d value. So there's no vertical displacement. So again, I could already tell you that the domain is going to be XER. The range is going to go from -3 to 3 because there's been no vertical displacement, but there has been an amplitude change. And now we can graph it. So we're looking at sine. Sine normally starts at 0, 0, but we are going to move that right one grid line. Then every 2 grid lines, I'm going to do a key point. And by doing a key point, I'm going to be going up to 3. So if there's nothing written here, assume that this is 1. So in 2 grid lines, 1, 2 grid lines, I'm going to go up to 3. 1, 2, 3. In another 2 grid lines, I'm going to go down to 0. In another 2 grid lines, I'm going to go down 3. In another 2 grid lines, I'm going to go back up to the midline. In another 2 grid lines, I'm going to go up to 3, back to 0, down to -3. Can't fit more. Make sure you go left, so 2 grid lines, down to -3. 2 grid lines, back up to 0. So we're going to connect our dots. Hopefully I haven't done any of them off. I'm sure you guys will tell me in the comments if I've done something weird. I'm sure I will. I miss having you guys to tell me when I make mistakes. And that is my graph of y equals 3 sine x minus a quarter. All right, as always, this would be a good place to pause the video and try one by yourself, but I will talk you through it. So if we're going to graph y equals cos of a quarter x, let's look ahead of time of what's going to happen. There is no a value. There's a 1 in here. There is a b value. My b is a quarter, which is going to be a horizontal stretch by 4. And then this is my d value. There's been no phase shift, but I'm going to go up by 3. So let's look at how to graph this. Let's look at our scale. There's 1, 2, 3, 4 grid lines to get to 2 pi. So my scale, every grid line is worth pi by 2. And again, feel free to put those in here if you want. I find it just gets my graph too cluttered if I put too many of them, but sometimes it can help with understanding. The amplitude of this graph is going to be 1 because the a value is 1. My period is going to be 2 pi divided by the b value of a quarter, so it's going to be 8 pi. So it's going to take 8 pi for one cycle to occur. My peak key points are going to happen every 8 pi divided by 4 because there's 4 key points per cycle, so every 2 pi. How many grid lines is 4 pi or 2 pi? Well, let's just look. 1, 2, 3, 4 grid lines. Yay! And do I have a phase shift? No. Do I have a vertical displacement? Yes. I'm going to go up 3. So again, I can already do my domain. It's always XER. My range, I have an amplitude of 1 and a displacement of 3. So I'm going to go down to 2 and then up to 4. And again, it's 3 minus 1, 3 plus 1. It's d minus a and d plus a. So then we go to graph it. And again, I haven't really cared if it's sine or cosine up until now, but now I want to look at the fact that this is cosine. So cosine normally starts at 0, 1, but that's going to be moved up 3. So instead of starting at 0, 1, we're going to go up 1, 2, 3, and we're going to start up here. Then every 4 grid lines, I'm going to go back and through the key points. So 1, 2, 3, 4 grid lines down to 0. 1, 2, 3, 4 grid lines down to 2. 1, 2, 3, 4 grid lines back up to 0, well, the center line, which is actually 3, and 1, 2, 3, 4 grid lines. I'm going to go back up to 4. And so then I'm going to repeat the cycle on the other side, 1, 2, 3, 4 grid lines to 3. And some people might find it handy, like once you know you've got a vertical displacement of 3. Maybe what you want to do is come in with a light pencil or something and you want to draw it in. So maybe I go in here and I go, okay, there's my center line. It's been moved up 3. And then you could just sort of go up and down 1 from there. It might just give you a visual base to go from. All right, finishing off this lesson. Instead of having to always do graphs, what I might want you to be able to do is just go from an equation and tell me all the different features. So the first thing I want to point out about these ones is they'll always be a little bit trickier. Oh, here, let me go back to a color you can see. I was kind of enjoying the purple. Let's switch it up. I'm going blue. Okay, so we are going to, first of all, I want you to notice that this is not in b times x minus c form. So the first thing you have to do is factor out the 3. So this is going to be y equals 2 sine 3 bracket x plus pi by 3. If you don't factor out the 3 first, you cannot see the phase shift or you will answer it wrong. Then amplitude is the absolute value of A, or 2. Period is 2 pi by B, or 2 pi by 3. The phase shift is left, pi by 3. The vertical displacement is down 4. You can see that with the D value. Your domain is XER. And then your range. So you're going down 4. So it's going to go from 4, and then your amplitude is 2. And then it's going to go up to 4 plus 2. So your range is going to be from 2 to 6. Awesome. Pause the video, try the next one, and then log back on. Okay. First thing I'm going to do is I'm going to factor the B. So I'm going to divide each of these terms by 2. So I'm going to get, yeah, we'll just put a 2. This should be a square bracket. 2 bracket x minus a quarter plus 5. So the amplitude is 1, although I am going to have a reflection of the y values over the x-axis. The period is 2 pi by 2, or pi. The phase shift is going to be right, pi by 4. The vertical displacement is up 5. Domain is XER. And the range is going to go from 5 minus 1 up to 5 plus 1. So it's going to go from 4 up to 6. All right, that is the end of 5.5 part 2, or 5.6 part 1, sorry. So we are going to be doing 5.6 part 2 on Monday, and hopefully I will have that video done by then. Talk soon.